So this week we're going to be talking about Chapter 3, which is System Software. All right. So there are three kind of big parts of system software. We have the operating system itself, and its job is to manage the system resources and provide an interface for you to communicate with hardware and other software. This is usually going to be stored on your hard drive on your computer. All right, now hard drive is getting to be a little, questionable. It's not necessarily, they're all hard drives still. I don't know if that's the best term anymore since we're now in the world of SSDs. So, hard drive or SSD is where your operating system is traditionally going to be stored. All right. We also have your system utilities, and this is part of your operating system install. And this is things that help keep your computer running, like the task manager or your network manager or, device manager, which shows you all the different things that are plugged into your computer. All right, so those are all types of different system utilities. All right. And then the last thing is our utility software, and this enables you to maintain, repair, and protect your computer. This may be included with the OS or purchased from another company. A good example of this would be virus software. All right. So you have Windows Defender, which is now built in, or you could download something like McAfee or Provost. I think Provast is another one. So there's a lot of different virus softwares out there, but that's just a little example for you. All right. Now, as part of our system resources, all right, we have a bunch of different things. So we've got the processor. All right. We talked about this last time, or I think it's like 2 weeks ago now. But when we were in Chapter 2, all right, we talked about the processor and your memory. All right. So that would be your RAM. All right. Just a reminder, your RAM is volatile, which means if you lose power to it, it's going to forget what it was remembering. All right. And part of your processor is kind of multitasking. All right, now we've gotten a lot simpler, I'll call it, with multitasking. All right, nowadays computers have multiple cores, and each of those cores sometimes has multiple threads. So we sometimes have 4 cores and 8 threads or something like that. All right, that's using what's called hyperthreading. But anyway, multitasking is going to make it appear as if your computer is doing more than one thing at a time. All right. Again, with multiple cores, we actually can do that. You can say, well, if I've got 4 cores, that means you're going to have 4 different things happening all at one point. All right. However, if you actually think about it, you might have more than 4 things happening. All right. If I look at my computer, what I have open right now, I have Chrome open, I have Outlook open, I have OBS, PLC software, Adobe, Word, Fusion, PowerPoint, and my Zoom window. All right. I have 8 different programs open right now. All right, and most of them are actively being used. So, 8 different things. If I only had a 4-core processor, that would mean that I have way too much going on. All right, so I can't just say this core is this program, this core is this program, this core is this program. All right, so in reality, the operating system is directing the processor to switch back and forth between tasks very quickly. All right, so it's basically looking at all those different programs, all those things that are different happening right now, and it's saying, okay, you need this and you need that, and the operating system is deciding which code it's running when and how it's going to do that. All right, and to help with multitasking, we have a memory area in the RAM, and each program running on your computer is assigned a memory area, and that keeps it from interfering with the process of other programs. All right. So by kind of segregating things in the RAM, it can keep track of where it is, what resources it needs, and all other things. And the RAM, because of what it is, it's really fast, which means the computer can load its stuff back from RAM very quickly. All right. It's not as quick as the memory, the cache that's built right into the CPU, but it's still extremely fast compared to our traditional hard drives. All right. All right. You might also have a buffer, and this uses RAM to temporarily hold data and instructions. All right. So kind of going back to that assigned memory area. So the OS allocates portions of the buffer as needed and manages the memory areas so that there's no interference between the applications. So that kind of, again, linked right in. We also do have virtual memory. All right. Now this is something that I would overall encourage you not to use anymore. Even with really fast SSDs and things, it can be helpful at times, but I would encourage you to try to, if necessary, get more RAM in your computer instead of using virtual memory. But when you don't have the money to buy more RAM, then sometimes virtual memory is your best option. All right. And what virtual memory is, it's an extension of the RAM, but it uses your hard drive. All right. So if you say I have 4 gigs of RAM on my computer and all the applications I'm using are calling for 8, what it does is it finds the memory that's least necessary. All right. So the stuff that's not being used necessarily right away. You know, like I have Adobe open right now. I'm not actively looking at that. I haven't touched that software since I got on my computer. It's open, but I'm not actively using it. So what it's going to do is it's going to take that RAM, that memory that's in RAM, and it's actually going to load it into my hard drive. All right, and we do this with swap files or paging files. All right, and this is how the virtual memory stores information. So it takes it and puts it on that hard drive in a very specific spot that it can go grab when it needs it. So that way, when I click Adobe and open it back up, what it does first is it finds RAM that I can empty out, or if there's enough open now, it moves it. And if there's not enough, it will take something that's on the RAM, move it to that virtual memory, and then it will grab the Adobe information and move it back to my RAM. All right, so it's constantly just moving information around. All right, and that process is called paging. That's the process of moving information from RAM to virtual memory, so moving things back and forth. All right. Oh, RAM, sorry. There's multitasking. I forgot to have these pictures. Here's our little virtual memory kind of picture. All right. All right, next we've got functions. All right. So when you first boot your computer or start the computer, the operating system goes through a process to detect all the devices that's connected to your computer. An operating system is going to establish communication with each device. And devices can include your monitor, speakers, keyboard, mouse, multimedia devices, printers, you know, kind of list just goes on and on. All right, and you can view those things, you know, in your device manager. All right, so if I just pull up my device manager for this computer, all right, that's going to be small. Throw it up here. I think it was 5. Of course, that's not working. Right, screen. There we go. No picture of me, but that's fine. So here you can see all the different devices that are on this computer. You can look at my ports, and you can see that I have one communication port. Those are my serial. If I look at my keyboards, I've got 4 HID keyboard devices. Not sure why there's 4 of them, but there are. We can come down here, and we can look at our mice and pointing devices. And again, I have 5 of those in there. All right. Look at my monitors. You can see there's 3 generic ones, my network adapters. All right. So you can see all the different devices just by expanding these things and looking at all the different stuff. So it can be very, very handy to have that device manager. All right. But anyway, the first thing your computer is going to do when you turn it on is it's going to post. All right. And post stands for a power on self-test. So that is a very important first step to the process. All right. So this is when it's going to test all the hardware that's built into the computer and make sure it's all working correctly. All right. So it's going, hey, there's a video card. There's a video card there. Okay, I see RAM. How much RAM do I see? Oh, I see 8 gigs of RAM. All right. Hey, the processor I see is this, and it's testing all these different things to making sure those things are going to work. Now, if something isn't working right, it will hopefully throw up an error message. Now, depending on how far through the post process that got, the error message could show up as text on your screen, or it could show up as beeping noises or light flashing on your motherboard. So it really comes down to, you know, what hardware problem there is, how far in the process it is, and what the system is it has for sending off these error codes. All right. So some motherboards, really high-end ones, have little numbers, little LCD screens that will show you exactly what the problem is. It'll be like E8 or F4 or whatever the case is. So it's a little give and take. The higher motherboards definitely make troubleshooting easier. All right. We also have plug and play. All right. This allows you to easily add new hardware to your computer by automatically setting it up to communicate with the computer. All right. How many you've installed? You plug your flash drive in the computer, and within 5-10 seconds, it normally just pops right up and ready for you to use. All right. That's plug and play right there. All right. You don't have to go find the driver. You don't have to tell it what to do. It's just it knows. I plug this in. There's a little bit of communication that's going on. It says, "Oh, I'm supposed to do XYZPQ," and it does it all for you. And it makes your life really easy. All right. We also have drivers. All right. And these are used as a translator to enable the computer and the device to communicate. All right. So if your mouse speaks French and your computer speaks English, we need a driver in between there to translate those instructions. All right. That's the quickest, easiest way to do this. All right. Device drivers can be added to your system, making it easy to upgrade to new devices. All right. That's really nice. It's like, okay, you're going to upgrade your video card. You can download the new driver ahead of time. When you're ready for it, you take the old one out, you put the new one in, and it finds that driver that you already installed and says, hey, I know what to do now. And it makes your life really, really easy, right? Oftentimes, there's a manufacturer disk that accompanies your devices, or at least there used to be. Nowadays, most things are downloaded from the internet. So Maybe you have a QR code that you scan on a piece of paper that takes you to their website. All right. The biggest benefit to doing that is you always have the most up-to-date driver compared to if you just include it on a disk in the packaging. All right. It's also cheaper, obviously, for the company to just send a piece of paper than an actual CD. And many people nowadays don't have CD drives on their computers. So even if they did, it wouldn't be easy for you to get the information off of that. All right. Flash drives, little like cheap flash drives would be the best way to do it nowadays if they're going to actually include it in the packaging. But very rarely do we do that. Now, to go along with device drivers, we also have firmware, all right? And this is software that's stored on a flash ROM chip, all right? ROM is read-only memory, all right? And it is non-volatile, so it does not erase when we lose power, all right? So the read-only memory is built into the device to provide instructions on how the device communicates with other computer hardware. So like your driver, your firmware might be built into the mouse that you're using if you have a really fancy mouse, all right? Or like the camera that you plug in, the web camera, that might have firmware built right into it. All right, so firmware is a little bit more difficult to update. It can be flashed or updated to enable a device to work with a new operating system or to make it work more effectively. All right, so little give and take. All right, another good example of firmware is the BIOS on your computer, the basic input-output system. All right, so that's the firmware that is on your motherboard. All right, so that is firmware that every time you turn your computer on, it's using. Next, we've got our application programming interface, or our API. All right, this is a favorite among developers. It's oh, do you have an API? Is kind of a big thing that developers like to know about. All right, this provides a way for communication between the operating system and the software, enabling the allocation of resources needed to run the application. There are a lot of common APIs that you have on your computer already, like file saving and printing requests. All right. But companies can have their own specialty API with their software. So maybe you have a way to integrate, a specific controller with, software, or whatever the case is. So the API allows other software to interact with this software. So a little bit of back and forth, but it definitely makes your life easier, especially as a programmer, if there's a good API available. And then another function might be some green computing. All right, so this is putting your computer into a low power mode so you can save on home cooling costs and prolong the life of your notebook battery. We also have power management features, and they're both standard in Windows and Mac. All right, so and Linux, I'm sure, has them as well. So green computing is definitely a big thing. All right, now there are some basics for your operating systems, and the first one's going to be your user interface. So how do we interact with the computer today? All right, so we're going to come back to the user interface in a minute. All right, so we have single and multi-user interfaces. And then we have embedded and mobile. All right, and I think we're going to come back to all of these things, so I don't think I need to talk too much about them right this second. All right. If not, we'll come back to that page. So the user interface, how do we use computers? All right. Most of the time nowadays, we are using what's called a GUI, a graphical user interface. All right, and that would be this bottom option right here. Not the eraser, I want the pen. Press the button, maybe. There we go. That is the one that most of us are familiar with. All right. And I'm getting ahead of myself. All right. So anyway, how we use computers. The OS is going to provide a way to interface that lets you interact with the computer. So in a command-driven interface, or in the commands, that's what we have over here on the right. So this one is the command-driven interface, the CDI. All right. So again, if you don't know Linux very well, so here is someone typing in different commands, and they're asking the computer to output information for them. All right. And then here would be the information that the computer is outputting. All right, so we change to a different folder. We can see that right here, and then there we can tell we're in that new folder. We're listing the files, and it says, hey, there's a total of 72 things in here, and now it starts to list them all. All right, so back with the command-driven interface, where you're manually typing your commands out. This is not going to be the most intuitive system. All right, it's actually very hard to use if you don't know what you're doing. You're going to have to constantly look things up. Am I typing things out right? All these wonderful things. Even when you do use it constantly, you're going to be like, is that the right command? Why doesn't this thing work? You type something in, and it's like, okay, didn't work. Let's try something else. We just constantly keep trying different things. All right. The big benefit to this is it's very easy to automate. So you can just be like, okay, I have a script, which is just a list of commands, and I want you to do this first, then this, then this. So you just make your list out for it, and then you can just run that one file, and boom, Bob's your uncle. You get your output at the end. It's all nice and easy. You don't have to go through and do things. All right. This type of system is still used today. All right. We have Windows Command Line or PowerShell. PowerShell is the newer one. All right. If you're in Linux, you've got the terminal. Mac, I think there's a terminal in Mac as well. All right. But the biggest benefit or the biggest downside is you need to know how the software works and what commands are available to you and what arguments to put and what formatting and all these other things. So if you've ever done computer programming, the command-driven interface might be a bit more up your alley. All right. Next, we've got a menu-driven interface. All right. I'm going to say, slowly getting away from these types of interfaces. But anyway, basically, we've got our menu here of all our different commands. So you'd pick a different thing and you'd say, okay, I want to do the Unicode command. So you'd do view, character encoding, and you'd say Unicode, and you'd click on that. All right, and that will send that information out for you. All right, so it's just like the command-driven interface, except for every command is under a toolbar or menu or something like that. So not the most intuitive unless you know where all the different commands are stored, but it definitely does, again, make your life easier than the straight-up command-driven interface. So a little give and take, but I said overall, I'd say we're still getting away from that one. Right? And then we have the last one, which is your GUI, which is your graphical user interface. Right? And again, that's the one that most people are used to using. So point and click, touch screen, whatever, nice pretty picture for you to look at, understand, and absorb all that information. So GUIs definitely are where we are kind of at. All right, now we basically hit this up last time, so I don't think I need to really go through all of this again. All right, but just as a fun little side note, this was, I don't have the year on this one. So it's probably a little outdated, but here you can see the market share. So Windows had 79.24% of the desktop when I made this. Mac had 14.65, Chrome was 1.35, and Linux was about 2%. All right. For the mobile market, which is what the picture is, Android was 85% and iOS was 13.28%. And yeah, like it's kind of interesting. I guess this is showing Windows too. So this is just showing you what the main operating system used in all these different areas is. So kind of interesting to see how Windows is the winner, then Android, and then iOS is the major one used in very specific areas. But again, iOS still has a very big market share. And actually, I know in the mobile, it's growing. All right. So operating systems for personal use. All right. We talked about Linux a little bit already, but we're going to focus a little bit more in this presentation. So Linux has what we call Tux the Penguin. All right, and that's that pretty little penguin guy there on the right. All right. There's a whole story about why the penguin is the mascot and how the creator and all that works. If you're really interested in finding that out, that's just you can read about it. I think it's a pretty funny story. All right. But anyway, Linux is an open source operating system designed for use of personal computers and web servers. Right? So it's open source, which means you can go download the source code for it and you can modify, tweak it, whatever you like. There's a lot going on there. We also have what's called distributions. And this is the combination of an operating system and a specific processor. It's referred to as the computer's platform. Sorry, distribution. Distributions are the operating system, and they normally combine that with a whole bunch of utilities, basically. So it's saying, okay, what's the purpose of this distribution? Is it just to have a straight-up GUI environment? Is it have a Linux environment? Are we just going extremely light because we want to use older hardware that's not meant for as much processing power, so we're going to try to strip out all the unnecessary junk? Or is this a high-end computer meant for gaming? So we need to include all the gaming infrastructure, the drivers, the software, all other fun things. So that's normally what your distributions are. And again, you can kind of pick and choose which distribution you like, and then you can always add software or remove software from that if necessary. All right. And then the question always comes down to upgrade your OS. All right. And it's, do you want to update to the newest features? And that's depending on your operating system. Can your hardware handle the new operating systems? Sometimes you will, sometimes you can't. And I will say that's one of the big benefits of Macs. They traditionally handle upgrades very well. Right. So, operating systems for machine, networks, and businesses. All right, so we have what's called real-time operating systems, or RTOSs. And these are specialized operating systems that are needed for machine, networks, and business that need to run in real time. All right, which means as soon as thing A happens, thing B has to happen right now. All right, we can't wait for the operating system to say, "Oh, let's run this code from this other section," and 30 seconds later, or 30 milliseconds in the world of computers, but still 30 milliseconds can be a long time for a robot that's shoving you into the wall when the pressure sensor was tripped. We need to have those real-time things. All right, so machines that perform a entire series of tasks might use them. Point-of-sale systems, car engines. Again, make sure we fire the spark plugs at the exact right moment. Robotics, things that require very precise timing, medical equipment, those types of things. All right. We also have multi-user operating systems. All right. Unix is a big one for that. It's a multi-user and multitasking OS that is used for a network operating system. A network operating system software allows multiple computers to communicate, share files, hardware devices with one another. All right, so again, they're all about sharing their resources. I highly suggest if you have the opportunity, set up a server for yourself and have a network operating system server type of thing. I use Proxmox at home, but even if you just said, okay, I'm gonna have a Windows computer, that's my server, and it runs all of your random hardware. I have Plex running on it. I have my OpenHAB home automation system. I have file sharing. I had printer sharing on it for a while. We changed printers. I didn't need to do that anymore. So there's a lot of good capabilities from having a server set up at your house. All right. As for OS coordination, all right, again, that's just making sure everything's working when it's supposed to be working. And we also have peer-to-peer, which is P2P, all right, where each computer is considered an equal. So we have the network stuff, server and client, and we have peer-to-peer where everyone's just the same thing. So we're going to share resources using feature built into the OS. So instead of having to use a server to do all the hard backend, it's just like, well, I have this Windows computer connected to this printer, you have that Windows computer connected to that printer. If I want to print to your printer, I will send it to your computer and your computer will print for me. Whereas if you have a server running and connected to all the printers, then you send your information to the server then spits it out to each printer. So it's a kind of the same thing, but it's slightly different because you don't have one like server device. It's everyone is an equal opportunity person. All right. We also have what's called a virtual desktop interface, VDIs. These are big in corporations and places. And the big benefit to VDIs is you have one super powerful computer somewhere, or multiple super powerful computers, and they're sharing their resources with the not so powerful computers that you have in the classrooms or computer labs or things like that. And this allows you to maintain the equipment easier. So if every time you had to do an operating system update to 20 computers in a lab, you have to go to each one, turn each one on, log in, start the update, go to the next one, start it, and sit and wait around for all of them they've done, that can take a very long time. With a VDI, you actually start with an image. So every time you log into the VDI, it grabs the image and then loads it from that. So all you have to do with a virtual desktop interface system is update one image, and it updates every person who logs into that computer. So it's a much better IT system. Now, so many users don't like them. They tend to feel slower and sluggish because all this data is going over the network and things like that. So it's not a perfect system, but it's definitely helpful. We also have lots of file types. All right. And the one interesting thing to me is the whole purpose of a file type or a file extension, all right, is to tell the computer, the operating system, what program to open that file with. All right. The file type, .doc, it doesn't change anything in the actual document, all right? But it does change when they say, oh, DOC, and your computer goes, I open that with Word. And it's like text, TXT, it's like, I open that with Notepad. That's the whole point of that file extension, is to tell the computer, hey, this is the program that we link to this file extension. You can open basically any file you want in any other file. All right, let's go to my downloads here. I've got a whole bunch of PDFs here. So I'm going to right click and I'm going to say edit with Notepad++. And here we can see the raw data that is in this file. Now, obviously this means basically jack diddly to us. All right. But to Adobe, this means a lot. All right. So it's very interesting to me that you can just, open any file you want in like Notepad or Word or whatever the case is. All right. Here's a picture file for PNG. All right. Wish I had an SVG file or something, but I don't think I have any really easy access. So it's just kind of interesting to me how That's the whole point of the file extension. All right, it's very important to have all these, but it's just, yeah, kind of how it's used. All right. Yeah. So file names, it has two parts. You have the actual name of the file extension. So that's what follows a period. All right. Windows file names can be up to 260 characters long in Windows. That might have changed with the newer version. I'm not so sure. You can use spacious and special characters such as underline hyphens and file names. All right. In Mac, it used to be 255 characters. All right. And then again, file extensions are separated from the file name by a period. All right. So you do need to be kind of careful about that. Personal opinion, just because I work in the world of Linux, using like spaces and other special characters and file names is a royal pain in the butt. All right. So I always try to avoid them. I try to use like a hyphen instead of a space or something like that. But to each their own. It really doesn't matter in Windows. Everything works just fine. It's just gets a little interesting sometimes. So I like to try to avoid that. Over here on the right, these are all different hard drive file systems. All right. I'm not going to go super in depth for them all. All right. But we have FAT, and there's FAT16 and FAT32. All right. And as we've started having larger hard drives and things like that, the file size on these things have gotten bigger. So with FAT16, you could have a max hard drive size of 4 gigabytes. With FAT32, the max hard drive size is now 2 terabytes. All right, if you need to get past that, you into exFAT, extended FAT system. We also have NTFS, which is the most common file system for Windows. We have Refs. This was developed for the Windows 8 server. We have HFS, which is the Mac OS standard. All right, this is obsolete. It's being phased out by Apple. So yep, we have HFS Plus. This is the new standard. We have APFS, which is the Apple file system. That's replacing the HFS Plus. We also have UFS-BE and UFS-LE. We've got extended EXT 2, 3, and 4, depending on the generation of the Linux file system. We have XFS. We've got BTRFS, we've got RAW, like there's a lot of different file system types. And you may be going, well, which one's the best? And the answer is, well, they all have their different benefits and their different drawbacks, all right? And again, if you're using Windows, you can't really use the Mac ones. They don't interface nicely. If you're using Mac, you can access the Windows ones pretty easily. So it's this like never-ending game, which is really annoying in the long run. We've got our File Explorer. All right. Again, we've already done a File Explorer assignment, but I'd just like to quick go over this one more time. So we've got tabs at the top. All right. You have your address bar right here. All right. Right now, it's just showing you library documents. If you were to click on that, it would break it down much more information for you. You've got your navigation pane over here on the right. We've got a search bar up there. We've got a folder list. So a lot going on there. All right. And then the last but not least for this chapter is cloud storage. All right. Someone once told me that all cloud storage is storing your files on someone else's computer, and that is not a lie. All right, that's all that cloud storage is. So whether you use iCloud, OneDrive, Google Drive, Dropbox, version after version after version, all it is someone else's computer. And the big question here is, do you trust them? Do you trust the people that you're storing your files with? And the answer to that needs to be yes if you're going to use them, or yes within reason. Right? It's like maybe I don't want to store my social security number on them, but if they have a copy of my pictures, I really don't care, right? It's like there's not anything that incriminating in my pictures. These are just my family pictures from all my family vacations. So it's a little bit of a give and take. All right. The big benefit to these cloud storage is that it's really easy to share files from one person to another. So we can oftentimes access them through a website or with a computer. Or an application or something like that. So it is a lot of give and take going on here with cloud storage. Now, personally, I use actually both Google Drive for all of my personal things, and I use OneDrive for all my HEC related things. So I do use both of them. There's another one called pCloud that I have access to. I had a Dropbox at one point. I do not have an iCloud. But yeah, no, it comes down to, do you trust them? And again, I can't give you oh, you should trust these and you can't trust those type of answer. All right. You do for your personal data for backing up. It's what's called 3-2-1. You want 3 copies of your data at 2 different locations, and I forget what the one is. I think with get you one back up. 1 copy offsite. That's what it is. So 3 copies, 2 different medias. So you want to store it on your external hard drive, and a USB flash drive, DVD, NAS, cloud storage, whatever the case is. They want 1 copy offsite. All right. So the cloud storage makes the offsite backup really easy, really convenient. All right. But if you don't trust them, you don't want to store your important documents there. So it is definitely a lot of a give and take going on here on what you want to do. All right, and that is the end of chapter 3. That was not the software I wanted. Does anybody have any questions for me?